Alright, so we're going to practice writing some equations from word problems. These word problems are totally boring. I'm sorry. But they're boring because they're very simple. They're not really based on the real world. They're just the most simple, most abstract you can get for the purpose of practice. And then once you master the art of writing equations, then you can get into the awesome stuff that's based on nature and you know things that are rooted in the real world. So let's just go through these three examples. I want to show you that you can have variables or unknown values on either side of the equation, and even both sides of the equation. So let me go through these examples and kind of show you the thought process behind taking a word problem and turning it into an equation. And you'll do this later on in life, if you are a scientist or a mathematician or a statistician, you'll be confronted with things that you observe in the real world, and you'll need to be able to distill that down into a mathematical equation so you can figure out what's going on. So that's what this skill is all about. So let's just go through these word problems that are very abstract, um, and just practice the skill. So six more than first one. Six more than. Okay, so let's just write what we know when we know it. So six more than something. So something at some point we're going to be adding six. Six more than. Um, six more than two times seven. So the six more than it's six more than two times seven. So actually, let me write it down here. That's what I meant to do. So we've got two times seven, and we've got six more than that. Six more than two times seven. And I'm just putting this in parentheses just to emphasize the correct order of operations, that you would do the multiplication before you do the addition. You don't have to put the parentheses. I was just doing that because I thought it'd be clear. Okay, 6 more than 2 times 7 is, that's where the equal sign goes, is 10 more than, so we're going to be adding 10. 10 more than a number. Ding, ding, ding. There's the variable. A number. What number? We don't know. Is it 14? Is it 25,000? We don't know. So in algebra, when you don't know the value of something, you just label it with a symbol. Oftentimes X, oftentimes N. You can choose whatever letter you want. Let's just be boring. Say N. So that's a number. We don't know what number. So 6 more than 2 times 7 is 10 more than a number. There we go. And you could solve it. Um, you know, you don't have to pay attention to this, but just to prove that you could actually do something with this, 2 times 7 is 14 plus 6 would be 20, so 20 equals n plus 10. Um, so a number plus 10 is 20, so that number is actually, let's go backwards 10, so the number uh, is 10. But the purpose of this exercise is to practice this skill, setting up the equation so that you can solve it. Alright, so that's with a variable on the right side of the equation. And just a little side note, so our equation was 2 times 7 plus 6 equals n plus 10. It would be perfectly fine to flip it around. N plus 10 equals 2 times 7 plus 6. Doesn't matter which way the equation's pointing. It's most natural to write it in the way that the word problem is written. But anyway, this means the same thing. Okay, 3 times a number. Okay, 3 times a number. 3 times a number. What are we gonna call a number? We don't know what the value is, so it's gonna be a variable. We're gonna symbolize it with a letter. Let's call it p. 3p. 3 times p. So 3 times a number, 3p, is equal, is 1 less than, 1 less than, so we're gonna subtract 1 at a certain point. Alright, it's 1 less than what? 2 times 11. 2 times 11. So I don't know, it's kind of sloppy, so let me write this. So 3p, or 3 times p. You can write the multiplication sign, 3 dot p, or you can just write it as 3p. Means the same thing. 3p means 3 times p. 3p equals 2 times 11 minus 1. So that's how you write that. So here are the variables on the left side. And again, we could, this would be equivalent to 2 times 11 minus 1 equals 3p. It doesn't really matter the direction that you go in. So, and we could solve that if we wanted to. You do 2 times 11 first, and then you subtract 1. So that would be 2 times 11 is 22, subtract 1 is 21. 21 equals 3p. 3 times p is 21, so what's p? P is 7. 7 times 3 is 21. Anyway, don't need to solve it now. Just need to set up the equation. Alright, last one. 2 times a number. So, okay. So 2 times a number. 2. Alright, what are we going to call the variable? Let's call it k. 2 times a number, 2k, is 3 more than, so we're going to be adding 3 to something, 3 more than that number. So whatever that number, so we have to call that k. So whatever that number is, 2 times that number is 3 more than that number itself. So k plus 3. So 2 times a number, and we're calling that number k, we don't know what value it has, is 3 more than that number. And we could solve that. I'll just show you how to solve it just for fun. So 2k equals k plus 3. What you could do is you could subtract the k from this side. Whatever you do at one side, you have to do the other. So 2k minus 1k is just k. K equals, all that's left here is 3. So 2 times 3 is 3 more than 3 is basically what that's saying. So there's this go. And so you might have the variable on the right side. You might have it on the left side. You might have the variable on both sides of the equation. Just follow the word problem. Write down what you know when you know it, and then it'll figure itself out. No problem.